In this video, I provide a description of my solution to question 2 of homework 9, where we're given a Poisson process xt, which takes on the value of t if n is odd on the interval 0 to t, and -2 if n is even on the interval 0 to 2. And we asked first to draw some samples of this process. So the process looks something of this sort, where you can see that if you have, for example, 2 points, then it's negative. If you have 1 point only, then it's positive. Then you asked next to find the probability that xt is equal to 2, which is the same as xt being odd on any interval t. But we first show some mathematical manipulation, where we know the exponential function is given by 1 plus the value of the exponent plus this plus this plus this. And for the negative, we just substitute negative lambda and get these two functions. When we subtract them, we get something of this form with only the odd terms. And then we create a format which is similar to the Poisson probability function. So we know from before that probability xt is equal to 2 requires an odd distribution. So that becomes for 1, for 3, for 5, and etc. And you can see that this function here is very similar. It's exactly the same as what we got from our manipulation above here. So this is equal to this, which we put here. The next we asked to find expected value of xt, but first we need to find probability that xt is equal to -2, which we do first by doing some mathematical manipulation. We get our semi-equations from above, 1 and 2. Instead of subtracting, we are now adding, so that we get the even components. So we do 1 plus 2, we end up with the even components on the right hand side. And the same way, we create a function that's similar to the Poisson, which is this. So from there, we know that probability xt is equal to -2 requires an even number of points on the interval. So we take for k is equal to k is even for the Poisson function. And we've already seen that this is exactly this. And an expectation is simply the value times probability. And we do that for +2 and -2, which are the only values. And we end up with something of this form, -2 exponential -2 lambda t. Next, we asked to find the autocorrelation function. And we know that for the function to be even, it needs to take on either +2 and +2, or -2 and -2. While for it to be odd, it has to take on +2 with -2, or -2 with +2. So first we assume that t2 is greater than t1, and we write out the formula for autocorrelation, which is expected value of xt1 xt2 times the value itself, plus on this other side probability with the value. Then we simply substitute for each of these probabilities, which we've already derived above, this and this, and we end up with something of this form. But this is for the case when t2 is greater than t1. Now when t1 is greater than t2, simply there will be a change in this power here. Instead of t2 minus t1, it will become t1 minus t2. So a simple formula would be magnitude of t2 minus t1. So next we asked if xt is wide sense stationary, and yes, we can conclude that it is, because the expected value is a constant, 0, and autocorrelation is a function of only the lag t2 minus t1.